On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to find the equation of a tangent line or lines when x is equal to 1. And we have this curve given down here, and it is given to us implicitly. We have some x's and y's all mixed together. This is a good indicator that you're going to need to use implicit differentiation. Now, here's what this curve looks like. If we look over in Desmos, I have this exact same curve typed in, and it's a sideways ellipse. And we want to find the equation of a tangent line when x equals 1. Well, x is equal to 1 here, but notice x is also equal to 1 somewhere down in here as well. So we're going to have two tangent lines here. Now, one of them may be kind of obvious. It's going to be a horizontal line, but I want to show you how to get both of these equations first by using implicit differentiation. So whenever you need to find the equation of a tangent line, you want to first start off by finding the derivative. So the derivative of x squared is going to be 2x. And now here, be very careful. X times y is a product. Therefore, we have to use the product rule for this. I'm going to call the x my f, and the y, I'm going to call it my g. And recall the product rule here. So it is a minus. We want to be careful with that. And then I'm going to put the product rule in parentheses. That minus gets brought down right here. So the product rule, let's take f prime times g. F prime, well, the derivative of x is just going to be 1. G, we leave it alone, plus g prime f. Now check out what we're getting ready to do. G prime is the derivative of y. The derivative of y is 1, but using implicit differentiation, tack on a y prime or a dy dx there. I'm going to use y prime for this tutorial. So this is g prime, and now we multiply by f. Again, this is the product rule. F prime g plus g prime f. Now let's finish this off. Plus y squared. Here's another derivative term that we're differentiating a y. The derivative of y squared is 2y. Tack on the y prime, and now this is equal to not 3, it's equal to 0 because the derivative of a constant is 0. Now let's work on getting y prime by itself. You don't have to do that in this case, but I'm going to go ahead and do that anyway. So distributing this negative 2x minus y prime x, I distributed the negative here and here. Now let's bring down the plus 2y, y prime, this is equal to 0. Notice this term here and this term here have a y prime in it. These two terms do not. Therefore, let's move these over to the right-hand side. That gives us negative y prime x plus 2y y prime is equal to, again, moving both of these over here, we have y minus 2x. Now that we have the terms that have y primes all by themselves on one side, let's factor the y prime out of both of these terms. Factoring the y prime out, we're left with negative x plus the 2y. This is still equal to the same stuff we have over here. And then last but not least, to get y prime by itself, let's divide by all of this stuff since y prime is getting multiplied by it. Therefore, we have y prime is equal to y minus 2x all over this stuff, negative x plus 2y. So this is our derivative. This is the slope of the tangent line. Now remember, we wanted to find the equation of the tangent line when x is equal to 1. But notice our derivative has both a x and a y in it. So what we need to do now is we need to find the value of y when x is 1. That way we can plug it into here and we can find our derivatives. So to do that, let's take that equation, x squared minus xy plus y squared, and let's plug 1 into x. So plugging 1 into x, we have 1 squared, which is 1, minus 1 times y, that's just y, plus y squared. This is equal to 3. Now what we have here is a quadratic that we're going to have to solve in order to figure out our values for y. Recall earlier I did mention when x is equal to 1, we have a y value here. We're going to get 2, and then we're going to have another y value down here, which looks like it's going to be negative 1. Let's see how to get that. I'm going to move this 3 over here and rearrange this thing. So y squared, bringing it on down, minus y And then when we subtract 3 over here, we get a negative 2 because 1 minus that 3 will give us a negative 2 down here. And this is going to be equal to 0. Now we can factor this quadratic to be y minus 2, y plus 1 is equal to 0. And now we have two values of y. Notice we have y equals 2 and y equals negative 1. So we have two spots when x is equal to 1. So again, notice those two dots are on this green curve here. 1, 2, x is 1, we have a y value of 2, and also when x is 1, we have a y value of negative 1. We're going to have two different tangent lines here. Let's find them both. So at 1, 2, when x is 1, we did get a y value of 2. Y prime is going to be equal to, let's plug everything in, so plugging the 2 into y, minus 2 times x, well that's just 2 times 1, so we get 2 over negative 1 plus 2 times y. Well, 2 times 2 gives us 4. It doesn't really matter because our numerator is 0, our denominator will be 3, therefore our slope here is going to be 0. Our derivative at the point 1, 2 is going to be equal to 0. Let's go ahead and repeat this for the point 1, negative 1. So very similar, plugging in 1 into x's and the negative 1 into the y spots. Therefore, we have negative 1 minus 2 times a 1, that's minus 2, over negative x, so that's negative 1, plus 2 times y, well 2 times a negative 1 is a negative 2. Working all this out, 1 minus 2, or excuse me, negative 1 minus 2, we get negative 3, over negative 1 minus 2 is a negative 3. Therefore, our slope, our derivative, the slope of our tangent line here is going to be 1. Now, these are just the derivatives. Let's find the equations of our tangent lines. So coming right back up here to this one, we had the point 1, 2, and we had a slope of 0. So using point slope form, y minus y1, which is 2, equals m, our derivative, that's 0, times x minus x1, which is a 1. So working all this out, we have y minus 2 is equal to 0 times this stuff is still going to be 0, which gives us a horizontal line of y equals 2. This is going to be one of our tangent lines. Let's go ahead and repeat this process for this point here using this slope now, and then we'll go over into Desmos and see that both of these tangent lines do work out right. So using this point and this slope now, we now have y minus y1, that's a negative 1. So how about I go ahead and say y plus 1 equals m, our slope of 1 times x minus x1, which is a 1. Working all this out, getting y by itself, y plus 1 is equal to x minus 1, just doing a little bit of distributive property there. And then subtracting 1 to get y by itself, we have y equals x minus 2. These are our two tangent lines when x is equal to 1 on that curve. And notice here, this is the first tangent line we found of y equals 2, that horizontal line. And then this second tangent line, y equals x minus 2. Notice this red line here is tangent to the green curve at that point 1, negative 1. All of this was found using implicit differentiation, taking the value of 1 for x, plugging it back into here to get two different values of y. We had two derivatives, which led us to finding two tangent lines. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.